Hello students, so today we are going to solve exercise questions. Okay. Exercise 2.2. First question is 3 sine inverse of x is equal to sine inverse 3x minus 4x cube. Okay, now looking at this equation, you will understand that this is trigonometric identity, that is sine 3 theta. So you can put x equal to sine theta. Okay, so put x equal to sine theta. So we'll get theta as sine inverse of x. So substituting this x in our RHS, we'll get sine inverse of 3 sine theta minus 4 sine cube theta. Okay, so sine inverse of, this is your sine 3 theta. So using the property of inverse trigonometric functions, you will get this as 3 theta and our theta is sine inverse of x. Okay. Similarly, it is for the second question. Okay, there you have to take cos 3 theta. Okay, that is cos 3x. You have to use the trigonometric identity of 11th standard. Let's solve question 3. Okay, here also you have to use the inverse trigonometric property. 2 by 11 plus tan inverse 7 upon 24 equal to tan inverse half. This you have to prove. Okay, so starting from LHS, you have to use identity tan inverse of x plus tan inverse of y. Okay, so this becomes tan inverse x plus y upon 1 minus x into y. Okay, so this is tan inverse. This will be 24 2s are 48 plus 77 upon 24 into 11 upon 24 into 11. So it is 44, 11 2s are 22, 22 plus 4, 26. 14 upon 24 into 11. So this denominator gets cancelled and you'll get tan inverse 125 upon, this is 250. Okay, so this is 125 ones are, this is 2s are, so we'll get tan inverse half, which is our RHS. Okay, same way question number 4, it is slightly different. Okay, for question number 4 you have to make use of 2 tan inverse of x. Okay, that formula you have to use. So the question is 2 tan inverse half plus tan inverse 1 by 7 equal to tan inverse 31 by 70. Okay, so make use of 2 tan inverse of x formula. So it is 2 tan inverse of x formula is tan inverse 2x upon 1 minus x square. Okay, here our x is half, so start using that. So LHS is tan inverse into 2x, so 2 into half upon 1 minus x square, so half square. Okay, and this thing remains same. So this is our tan inverse 1 upon 4 minus 1 3 by 4. So it will be 4 by 3. Now you have to make use of tan inverse of x plus tan inverse of y formula. So tan inverse 4 by 3 plus 1 by 7 upon 1 minus 4 by 3 into 1 by 7. Okay, so this will be 28 plus 3 31. Denominators gets cancelled, so 28 minus 4, so 24. No, 21 minus 4, so 70. Okay, so this is the answer. Next question is, you have to write it in the simplest form. Okay, so tan inverse root of 1 minus x square minus 1 upon x. So this thing you have to write it in the simplest form. So I'll substitute x equal to tan theta. Okay, so theta will be our tan inverse of x. Let's see what we get. So tan inverse root of 1 minus tan square theta minus 1 upon tan theta. Okay, 1 minus tan square theta is sec square theta, so its root is sec theta. Okay, so sec theta minus 1 upon tan theta. Now sec theta we can write it as 1 upon cos theta, so 1 minus cos theta upon cos theta, cross multiplying, and tan theta is our sin theta upon cos theta. Okay, so this we have used because we want to use the half angle formula. So tan inverse 1 minus cos theta, using half angle you will get 2 sin square theta by 2, and sin theta you can write it as 2 sin theta by 2 into cos theta by 2. These are the half angle formulas. So 2 gets cancelled, sin theta, so 1 sin theta by 2 remains, and upon cos theta by 2, which is our tan theta by 2. So tan inverse tan theta by 2, you will get theta by 2, and theta is our tan inverse, so tan inverse of x by 2 is the answer. Okay, that is the simplest form. Next question is, you have to make it again in the simplest form. So sixth one, tan inverse 1 upon root of x square minus 1. Okay, now look here, so tan inverse of tan of something we want, right? So to get here tan, we need here cot. Okay, and we know from the trigonometric identities how we got cot. So that is cosec square theta minus 1, you will get cot square theta, right? So substituting x equal to cosec of theta, so our theta is cosec inverse of x. Okay, so tan inverse 1 upon root of cosec square theta minus 1, which is cot square theta, and cot square and root gets cancelled, so you will get tan inverse of 1 upon cot, which is nothing but tan of theta. Okay, so tan inverse tan of theta is theta is cosec inverse of x. Okay, this is the answer. Next is tan inverse root of 1 minus cos x upon 1 plus cos x. Now looking at this equation, you will realize that you have to use half angle formula. Okay, so directly using half angle formula, you will get tan inverse under root 1 minus cos x is 2 sin square x by 2 upon 1 plus cos x is 2 cos square x by 2. Okay, so 2 gets cancelled. This will be our tan square x by 2, which is under root. So you will get tan inverse tan x by 2. Okay, so using the property, final answer is x by 2. Okay, same way for question 8. Okay. So for question 8, it is given tan inverse cos of x minus sin of x. If you have solved trigonometric identities last year, okay, you will easily understand what to substitute here. Okay, so what to do here? So this is, you have to make it as a tan, so you have to divide both numerator and denominator by cos of x, right? So dividing numerator and denominator by cos of x inside the bracket. Okay, so we'll get tan inverse, so cos of x upon cos of x will get 1, sin of x upon cos of x will get tan of x, upon this will be 1 plus tan of x. Okay, and this is nothing but our tan inverse. We have solved one question based on this. So this is tan of a plus b formula, that is tan of pi by 4. Here minus sign is there, so you have to use minus x. So this is tan of a minus b. Okay, so final answer is pi by 4 minus x. Okay. Next question, question number 9. Okay, tan inverse x upon root of a square minus x square. Okay, so here first should know that we want a term in tan here. Okay, so to get this in tan, we need to substitute here such a way that we should get here cos. Okay, to get cos here, we need 1 minus sin square, right? So substituting x as sine, you will get the answer. But here a is also there, so you have to substitute x equal to a sine theta. Okay, so from this theta will be sine inverse of x by. So tan inverse x is our a sine theta, so root of a square minus a square sine square theta. Okay, so tan inverse a sine theta upon a square we can take common, so under root you will get outside a, and inside you will get 1 minus sine square theta, which is cos square theta. Now cos square theta under root you will get cos theta, so a gets cancelled, and this will be tan inverse tan of theta, and theta we know that it is sine inverse x by. Okay, next question is very simple. Okay, so looking at that equation, that is 3a square x minus x cube upon a cube minus 3a x square, you will realize that that is nothing but tan 3 theta formula, right? So you have to substitute, since a is there, you have to substitute x equal to a tan theta. So you will get tan 3 theta inside the bracket, and the final answer will be 3 tan inverse x by, which you can do it on yours. Question 11. Okay, you have to find the value of tan inverse 2 cos 2 sin inverse half. Okay, so you have to first solve the one which is in the bracket. So you can directly write if you know the value. So sine inverse of half means half is a sine of theta, that theta will be 30 degree, right? So we can write pi by 6. So this will be pi by 3. So you can write value of cos of pi by 3, so which is cos of 60. Cos 60 is again half, so we'll get tan inverse of 1. Tan inverse of 1 is nothing but pi by 4. Okay. Next question, question number 12. They have given cot tan inverse of A plus cot inverse of A. Here you have to make use of the property which is given in inverse trigonometric functions. So that property is tan inverse of x plus cot inverse of x equal to pi by 2. So simply you have to substitute over there pi by 2. Okay. Next question we'll solve. Question number 13. Tan half sine inverse 2x upon 1 plus x square plus cos inverse 1 minus y square upon 1 plus y square. Okay. Now to solve this, first you have to solve the bracket. Okay. Now here we have given this sine inverse 2x upon 1 plus x square. Now we know that looking at this, we know that this x will be our tan theta, because this will come in sine 2 theta form, right? Because we have done one property based on this. Okay. Similarly for y also you will get here cos 2 theta formula, that is trigonometric identity. So substituting x equal to tan theta and y equal to some other angle you have to take, tan phi. Okay, so you will get sine inverse 2 tan theta upon 1 plus tan square theta, which is nothing but sine 2 theta. So our final answer is 2 theta. So theta is tan inverse of x. Okay. Similarly, substituting in cos inverse, you will get 1 minus tan square phi upon 1 plus tan square phi. So cos inverse, this will be cos 2 theta. So you will get again 2 theta. So 2 into tan inverse of phi. Okay, phi. Now substituting it in the original equation. So in place of this you will get 2 tan inverse of x, and here it will be 2 tan inverse of y. Okay, I will write it here only. So 2 I can take outside, so it will get cancelled with this half. So tan inverse of x plus tan inverse of y. So here you can use the formula tan inverse of x plus tan inverse of y. So you will get tan inverse x plus y upon 1 minus xy. So using the property you will get the final answer x plus y upon 1 minus xy. Okay. Next question is question number 14. So sine inverse of 1 by 5 plus cos inverse of x equal to 1. This is given. You have to find value of x. Okay. Now if you look at this, this is in the form sine a plus b, right? So we know that this we can expand, sine a cos b cos a sine b. So writing it in this form, you will get sine a, so sine inverse of 1 by 5 into cos b, so cos of b, so cos of cos inverse of x plus cos of sine inverse of 1 by 5 into sine of cos inverse of x. Okay. So using the property, this will be sine of sine inverse of 1 by 5. You can write 1 by 5. Cos of cos inverse of x, you can write x plus, this is cos sine inverse of 1 by 5 and sine cos inverse of x. So this is equal to 1, it is given. So we have to find this sine inverse in terms of cos. Okay. So, and also we have to find cos inverse in terms of sine. So we can make use of the triangle method. Okay. So sine inverse of 1 by 5, I can write it as some y. So 1 by 5, so sine of y is 1 by 5. Okay. Using the triangle method, 1, 5, this will be 25 minus 1, so root of 24. Okay. So root of 24. So our cos y is root 24 upon 5. Okay. So cos inverse y equal to cos inverse of this, that will be root cos inverse of root 24 upon 5. Okay. That we can substitute here. Okay. Same way you have to find for cos inverse of x. So cos inverse of x, we can write it as some z. Okay. So our x is cos z. Now cos z, we can write it as 1 minus sine square z. Okay. So our z again will be sine inverse of this. I'll solve again. So I'll write first cos inverse root 24 upon 5. So this value will be cos of cos inverse root 24 upon 5. Okay. Now we are finding cos inverse of x. So taking cos inverse of x equal to some z. So x will be cos of z. Okay. Cos of z, we can write it as root of 1 minus sine square z. Okay. Again taking root, squaring both the sides, x square equal to 1 minus sine square z. So minus sine square z is x square minus 1 and z will be sine inverse of 1 minus x square. Okay. So this we have to substitute here in place of cos inverse of x. Sine inverse 1 minus root of 1 minus x square. Sine inverse root of 1 minus x square equal to 1. Okay. So using the property cos of cos inverse of x and sine of sine inverse of x, we will get here x upon 5 plus root of 24 upon 5 into root of 1 minus x square equal to 1. Okay. So you have to solve this equation. So here denominator 5 is there, which gets multiplied here. So you will get x plus root 24 root 1 minus x square equal to 5. So this x you can take here, so it will be here. Okay. Squaring both the sides, will get 24 into 1 minus x square equal to 25 minus 50x plus x square. Okay. and this will be 24 minus 24x square equal to 25 minus 50x plus x square. So this you can take that side, 24 also that side. You will get 24x square. So 25x square, 25 minus 24, 1, 50x plus 1 equal to 0. This is the quadratic equation, and you can make use of quadratic formula. Okay, five twos are 10. Okay, this is 10, sorry. So this will be 10. Okay, so if you find the factors, you will get 25 and minus 10. So 5 5s are, okay, you will get minus 5 minus 5. (25x square minus 5x minus 5x plus 1 equal to 0. So you will get 5x minus 1 the whole square. 5x minus 1 the whole square equal to 0. So your x is 1 by 5. Okay. So x you will get 1 by 5. This is the answer.